Alright class, so let's look at our very last problem here for chapter 8, and this problem involves quite a lot of information that we will use from the entire chapter, okay? We're going to need to know how to use bearings. In drawing this shape, we're going to see it becomes a quadrilateral, and in that we'll need law of sines and law of cosines to be able to find different parts of the quadrilateral that got split up into two triangles, and then we'll need to find the area of those two triangles. So there's a lot of stuff going on here. Okay. Let's go ahead and begin by drawing our shape. It says from a cement marker, proceed 260 meters southwest to the river. And what it means by saying southwest is you're going directly southwest, so that's going to give you a 45-degree angle. So we're going to start by drawing our diagram with our compass bearings with north, south, east, and west. And we're going to go 260 meters southwest. Southwest will take us this way. And that'll be an angle measurement of 45 degrees in both sides because, well, southwest is right down the middle. This is going to be a length of 260 meters. And we're going to go all the way until we hit the river. And the river will have another compass reading there. And this is the river here. This is the cement marker here. Okay. And then from there, from the river, we're going to go 240 meters south. So we're going to go down 240 meters. And then we're going to hit the bridge. So at this point, we're going to hit the bridge right here. And then once we reach the bridge, we're going to go 280 meters north, 40 degrees east. So 40 degrees east and 280 meters will look something like this. Oh, that's a terrible drawing. Forgive me. Anyway, this is 280 meters there. And we know that this angle measurement is 40 degrees. Okay. Now, I know right now it does look like it's a parallelogram, but keep in mind that this is supposed to be a 45-degree angle measurement based on what you know from geometry, right? We have alternate interior angles. So do realize that these actually are not the same angle measurement. I know it looks parallel, but it really isn't, okay? So from here, we're just going to go ahead and place our other marker. This is when we reach Sycamore Lane. And 280 meters is a little bit longer than 260 meters, so it is going to extend a little bit more outward to the right-hand side. Okay, from there, we are going to go from Sycamore Lane back to the cement marker, and so we'll draw another side like that. Okay? It says find the area of the plot. So with this like real-life application, you know, people actually do this. They need to be able to plot the amount of land and calculate its area so that they can do whatever they need to with that plot of land. Okay. All right, so as you can see, what we have here is the drawing of a quadrilateral. I actually think let's see here, I'm just going to draw it over here. I'm just going to redraw my quadrilateral up here. I know I don't have a whole lot of space down here to do my work. If you need to, I'd recommend just doing it on a separate sheet of paper, just because there may be a lot of work involved. But in my case here, I'm just going to go ahead and draw this quadrilateral. And now, you know, it's going to look something like this, basically. And then now I know that also that because this is 45 degrees, and right here it's a 90-degree measure, that'll give us 90 plus 45, or that's going to give us a total of 135 degrees, just right in there. Okay. We know that this angle forms a 40-degree angle, so we're going to say 40 degrees here. We're going to say that each of those side lengths are 260, 240, and 280, and I think that's it. That's all the information that we're given. Okay, so from here, it's just a matter of us trying to figure out how to calculate area. As you recall from our previous video, we know that we can find area of quadrilaterals by breaking it up into two triangles. So let's go ahead and do that. Okay, so there's my two triangles. Now the question comes into play, which way do you want to break it up? Do you want to break it up this way, the way I've drawn my diagonal, or do you want to break it up the other way, going this way? And the answer really is it doesn't really matter. You can use either way. That's what's so great about this problem is there's no wrong answer. Okay, so you know, I'll break it up this way. If you want, feel free to break it up the other way. And let's just see if we get the same number at the very end. Okay, you can always try that on your own. So with what I have here, I do notice that I have side, angle, and side. And so, I'll just look for a couple of things. I'll need to find this dotted line. I'll need to find this angle here as well, since it's included with the 40 degrees. And then by finding that angle, I can then get this angle. And since I already know this side, and then I'll find this angle, I can do side, angle, side again, and then try and find the area of that triangle, and then find the area of that triangle, add them up, and that's basically how we're going to do the problem. Okay, so let's go ahead and get started. We're going to first find this side. We're going to do law of cosines. So x squared is equal to 240 squared plus 260 squared minus 2 times 240 times 260 times cosine of 135 degrees. All right, let's go ahead and enter that in our calculator. 240 squared plus 260 squared minus 2 times 240 times 260 times cosine of 135 degrees. Let me make sure I'm in the right mode. Yep, degree mode. I'm all good. Enter. So, oh my gosh, 213. Oh, and then don't forget, because that was x squared, we need to square root that answer. That'll make it nicer. And our answer is 462.003. I'm going to store this as alpha A. 462 basically. Okay. Go here. So x is basically 462, which I have stored as A. Okay, so I'll just keep that in mind. Alright, so now I know that this piece is 462. Another thing I'll need is I need to find this angle measurement here, so let's go ahead and do that. Let's see, how can we do that? I guess law of sines would work pretty well, right? We have this side over sine of 135, so we'll say, I'm going to just write it as A over sine of 135 is equal to find this angle, we can do 260 over sine of, let's call it angle B. Okay, so in solving for angle B, what we have is, let's go ahead and say A sine B equals 260 sine 135, and then divide both sides by A. Okay, all right, let's go ahead and find that. So 260 sine 135, 260 sine 135. I'm going to take that answer and then divide it by my alpha A, the answer I had from before, and we'll get 0.397. Keep in mind that that was the sine value of it. I want to find angle B, so I need to arc sine that answer. And that'll give us an angle measurement of 23.44 degrees, 449 degrees. 23.449. So angle B is going to be 23.449 degrees, and I'll store that as B itself. That'll make it nice and easy. Okay, so this angle right here is 23.449. Well, I guess the next order of business would be to start looking for our second triangle's parts. The second triangle parts, we'll need this, right? Which is going to be 40 minus that. Okay, so let me make sure I store that as B first. I'm going to take that answer, store it as B. I might need that later on, right? I'm going to store that as B. And then what I want to do with that value is then do the 40 degrees of that entire angle minus that value, 23.449, and we'll get 16.55 degrees. Okay, so this angle right here is going to be 16.55 degrees. I guess it makes sense. Let's just keep going with A, B, and let's call this angle C. Okay, so that's going to be angle C, 16.55 degrees. Alright, well, I think we have all of our information that we need, right? Let's now go ahead and calculate the area of both of our triangles. To calculate the area of our first triangle, what we see is that there's a measurement of 240, there's a measurement of 260, and there's an angle measurement of 135. We can use those. Or if you wanted, you can use 240. You can use your angle of 23.449, and you can also use your side length of 462. It doesn't matter. You're going to get the same area. So we'll say area is equal to, just make sure you plug in the right numbers though. In the case that I have here, I'm going to go ahead and multiply 1/2 times 240 times 260 times sine of 135. I apologize, I ran out of space there. Okay, so let's go ahead and do that. Half 240, half times 240 times 260 times sine of 135. Well, we know that's just basically sine of a 45-degree angle, which is root 2 over 2, but let's just get the decimal value there. That's an area of 22,061.73. 22,061.73. This is what, meters squared. Okay, so that's the area of our first triangle, this space right there. Okay, now we need to find the area of our second triangle. We want this space right here. Okay, and to find that, let's take our values of, I'm just going to draw the triangle here. Let's take the values that we know, which is 462. We also knew this angle measurement, which was 16.55 degrees, and we also knew that the side length was 280. So we can use our same area formula. Area equals half times 462 side length times 280 side length times sine of included angle 16.55 degrees. Or I believe I use that as my my angle C. Okay, so let's go ahead and find that. Okay, so half times 462 times 280 times sine of angle C. So that's my alpha C. And we're going to get an area of 18,425.07. 18,425.07, I believe. Okay, and so to find the total area now of the entire plot, we just take these values and add them up. Okay, so total area is our 22,061.73 plus 18,425.07. Let's go ahead and add that up. Okay, so we're going to add that with the 22,061.73, and we're going to get 40,486. 40,486. What was that? 0.79, I want to say. 0.79, what are we in? Meters squared is our total area. Okay, so that's how you do that problem. Nice and long. And that is it for Chapter 8.